So let's say you're doing the SAT reading and writing section. You flew through the first part and overall you're doing pretty good. You finally reach the middle section with the most challenging questions and prepare to crush them like the previous ones, when all of a sudden you see this. Now, at this part, many students stagnate and don't know what to do as the complicated terms and long text paired with graphs start to look like some ancient hieroglyphs rather than exam questions. If you've ever been in a situation like this or are now, then no worries, you're in luck, because in this video we're going to cover how to solve confusing questions like this, so by the end of it you should know how to easily find the correct answers, even to the hard ones. Well, without further ado, let's begin. So we're going to begin with an easy practice problem over here and figure out the strategies to answer questions like this quickly and accurately before solidifying it with harder examples. But first of all, what even are quantitative evidence questions? On questions like this, you'll be given some kind of graph or table about an unfamiliar topic with a paragraph and the question with answer choices. You must use the given information and probe both to best answer the idea being asked in the question. And what usually happens is people see a question like this, go straight to the answer choices, then to the graph and table, and end up jumping between the two, eventually wasting a lot of time on a single question, which is crucial on the test. Right now we're going to look at a few simple steps to easily answer questions like this by using this example. So the first thing you always want to do is skim the graph or table. Notice how I say skim. There's no need to be diving into the graph and deeply analyzing everything. What you want to do instead is note some important points which are going to give you a basic understanding of what is going on. Try looking at the title, labels, and the units. Like in this example. For instance, I instantly notice how it's saying days per winter, that lakes have surface ice, some days which are going up, and specific dates. And also below I can see some sort of names being given. This gives you context of what the question is about before you even start hunting for evidence, which you'll be looking for in the paragraph. Now, the next thing you want to do is go straight to the question stem, not the paragraph like some of you may have thought. This is because the question tells you exactly what you're trying to prove and what specific details to look for. Like, basically speaking, you can't answer a question if you don't know what the question is about. So instead of dispersing over the entirety of the paragraph or taking in unnecessary information, ask yourself, what exactly am I trying to prove? Let's look at our example here. Which choice most effectively uses data from the graph to complete the researcher's example? Aha, we see complete researcher's example. And this is an important detail because it tells us that we're basically trying to complete some example which is stated by a researcher in the text. And this is good because usually when saying to complete, the example is going to be in the last sentence, like over here. She cites a typical example, and from here on we can work backwards because chances are this example is going to be in the previous sentence. If we didn't look at the question first, we probably would have started from the beginning of the paragraph and wasted a lot of time, which isn't good. Just a side note, on the SAT reading and writing, there are some problems with identical questions like starting in English conventions, so skipping them can really save time. However, it is not the case with quantitative evidence questions because they are going to differ and ask for different things, as you can see right now on the screen. Pause if you need to and make some notes. This brings us to step 3, skimming the paragraph while identifying key details. The reason I use the word skim again is because the question has already highlighted what we should be looking for in the text. Our goal is not to read every word closely, but to understand the overall context while paying special attention to other ideas mentioned in the question. In this case, for example, the question directs us to focus on the sentence before the last one, which contains the evidence needed to answer correctly. The remaining sentences may provide background information to help us understand the passage and clarify the meaning of certain ideas. Basically, the context so we can overall understand what is going on. And now this brings us to our most important skill, summarizing in your own words. If you don't know how to summarize SAT paragraphs in your own words, you're basically done for. Okay, I am kidding. Right now we're going to look at how to summarize paragraphs easily without getting intimidated by large words and confusing texts. If you're just beginning, it might be useful to make some notes physically, but as the actual test, I strongly suggest keeping these notes and summaries in your head, because it really saves time. You can achieve that skill by practicing a lot of questions starting from easy levels and going on to the hard ones. Now, summarizing SAT paragraphs begins from breaking sentences down into simple ideas. It is actually pretty easy. Basically, all you have to do is translate a convoluted sentence into a simple everyday language which you can understand. Now, let's run back to our example over here and begin reading. It is common for freshwater lakes near or above latitude of 45 north of the equator, Lake. Now let's stop here for a second for a useful tip. On the SAT, it is usual to omit researcher names or long scientific or technical terms, and instead of trying to read these terms and fully understand them, abbreviate them. Good news is SAT reading and writing section will never ask you to define or decode these words. Simply shorten them in your mind so you can focus on the main idea of the passage, not the complex words. So here we can turn the names into letters like M and N instead of calling them their full names, Bjorna and Norway. Now this really helps us understand the paragraph better because now we don't have to remember any complicated words. And let's keep reading the sentence over here. To accumulate surface ice in winter. Now it is common for freshwater lakes near above the latitude 45 north of the equator, like Lake Amandan, to accumulate surface ice in winter. This sentence may seem quite confusing at first, which is why we have to transform it into our own simple words. It doesn't have to be long, just a very shortened version. For instance, I can say here, if it's above 45 something, then lake surface turns into ice. So you see how we took this very complicated and long sentence and turned it into a very simple bullet point. If you want to complete a full SAT paragraph, you'll have to turn every single sentence into a simple bullet point in your head. And if the question is also asking you for a main point of the paragraph or the overall structure, you can just take these bullet points and turn them into simple one idea. Now let's keep reading. The amount and duration of the ice depends on many factors, including local weather conditions, as well as lake depth, volume, and surface area. But a climate researcher, we see researcher, which is mentioned in the question, so we stop as it is an important detail, claims that some lakes in this latitude have seen a decline in the duration of ice between the early 1980s and the mid-2000s. Now, we see the word decline in the duration of ice between 1980s and mid-2000s, and we get excited because this is what we noted in the graph. So basically what this entire sentence is saying, that over the period of 1980s to the mid-2000s, there has been a decline in the latitude. Or to say differently, or how it's presented on the graph, duration or number of days. Now, to write it shortly, you can just say that days of ice lowers from 1980s to mid-2000s. Basically, we're seeing some sort of decline in the number of days the lake surface has persisted in different lakes. Basically, in this one simple sentence, we summarize the entire claim which the researcher was presenting, and this is exactly what we'll be looking for in the graph to find evidence. We need to find something that proves that from 1980s to mid-2000s there was a duration like a skew to down or lower returns in numbers in the amount of days. And this brings us to our fourth step is to check the answer choices and check if it fits the hypothesis, our hypothesis. Now, let's jump to the graph here and notice that it is saying both lake N and O, which had fewer than 995 days of ice in the winter of 80s to 81. Now, this one isn't conceptually correct because it is talking about some sort of decline. It's just talking about the number of days which were in the 1980s. So answer choice A is instantly wrong. Now B. Lake Anne, which had more days of ice between 2005 and 2006, it is the winter of 1980s. Now this is talking about an opposite thing because we see kind of rise because it is going up and not going down as time goes on. Oh, now for answer choice C. Oh, which had fewer days of ice in the winter of 2005 than did in the winter of 1980s. Now this one is like or less fits our hypothesis because it shows some kind of decline from 1980s to 2005 for a specific lake. And it doesn't matter which lake specifically because all we need to prove is that there was some sort of a decline in days. Now, since choice C fits our hypothesis, let's leave it for a while and jump to option C or D. Both Lake N and O, which had more of 105 days of ice in the winter of 2006. Now this option is almost the same as A because it talks about this only specific time and not mentioning the time before that, so answer choice D is wrong and that leaves us with answer choice C. Now let's move on to the next question. Now, the second problem over here might seem a little bit more intimidating because of all the complicated numbers and strange scientific names. However, I just suggest you to remember to abbreviate the jargon and notice on the bottom right that I left the steps on how to solve this problem. So again, I encourage you to stop the video and try to solve it for yourself. Now we're going to look at how to solve this problem if you probably pause the video and you have an answer in your head. First, we're going to skim the graph and instantly I see some mass, radius, days, distance from the sun, and some random numbers which I do not know the meaning of yet. Just quickly know them. Now we jump straight to the question. Which shows best describe the data from the table that support R and colleague as assertion. Now remember, we do not need names, we can just use something short like a letter instead. Now, since it's telling us to support some assertion, usually assertions are going to be in the last sentence, so we quickly can jump to the last sentence of the paragraph and outline the kind of assertion that they're talking about. Like here. Notice the last sentence. In 2021, Michigan State University astronomer, we see R announced the discovery of 5 new gas exoplanets and asserted that 4 are hot Jupiters and 1 is warm Jupiter. Now we know what they asserted, however we have no idea what hot Jupiters or warm Jupiters are, and for this type of context we need to skim the paragraph in our third step. We need to go to the back of the paragraph and skim the passage from the start to find phrases hot Jupiter and warm Jupiter to understand what they both mean, as they're going to be our key to answering this question. However, let's first shortly summarize the assertion made by R. Basically, what they're stating is that they're saying that they made some discovery about gas exoplanets and asserted that 4 of them are hot Jupiters and 1 is a warm Jupiter. Great, now that you've made our summary of the assertion made by the researcher, we can go back to the start of the sentence and start skimming the paragraph while looking for these two phrases, hot Jupiter and warm Jupiter. If you see them, you have to stop and read the sentence more closely. Now, right off the bat, we see a hot Jupiter at the start of the paragraph, and let's keep reading. Are gas planets that have mass. Now we instantly notice mass because it's mentioned in our graph and that it is at least 0.25 Jupiters. Now here we can, it's an orbital period of a little less than 10 days. Now we instantly outlined important points about the hot Jupiter that we should know, and at this point we can summarize what we know about it. So as a simple bullet point, we can write down that hot Jupiters means at least more than 0.5 in mass and less than 10 days. Now that we've made our first bullet point, let's keep reading. While warm Jupiters, we see warm Jupiters, are gas planets that meet the same mass criterion but have orbital periods of more than 10 days. Now, same mass criterion means that they're both basically at least 0.25 Jupiters and of more than 10 days. Now, from this point, we can make our second bullet point, and that is warm Jupiters are of the same mass, however, they are more than 10 days as compared to hot Jupiters. And this over here is going to be our second bullet point. And now, as we can see, we basically took this entire large and confusing paragraph and turned it into three very simple and understandable bullet points. Now let's jump back to our conclusion over here, and here it's asking us for evidence about 4 hot Jupiters that we already took a bullet point of, and evidence of 1 warm Jupiter that we also took a bullet point of. Now, to find evidence about these numbers, we'll have to jump to the graph and look for something which has a difference in days, because as we already checked, our masses are the same. So the thing we'll be looking for mainly are the difference in days between hot Jupiters and warm Jupiters. Now we instantly notice that orbital period are days, because we noted it before, and the only one that has a days more than 10 days is the 1478 one. I'm going to shorten planet 1478 and just call it 14, but basically from this we can draw a conclusion that planet 14 is the only warm Jupiter because it is the only planet which has an orbital period of more than 10 days. Now, this is exactly what we'll be trying to look for in the answer choices. The answer choice which states that planet 14 is the warm Jupiter due to its extended orbital period is the correct answer because it falls within our hypothesis. Now, let's check the answer choices one by one. A. None of the planets have an orbital period of more than 10 days. Now, at this point we can stop as this is clearly wrong due to this claim here that no planets have a orbital period of more than 10 days because we just discussed that planet 14 has more than 10 days. Now, in the next one, planet 14 has an orbital period of 153 days, and the masses of all the planets range from 0.85 to 6.33 Jupiters. Now, even though the masses here fall within the criteria and are correct, what really is the problem here is the orbital period of 153 days, because if we look back at the graph, we can notice that planet 14 has an orbital period of 10 with something days. It is not 153, which is actually the distance from the Sun from this specific question. Now, let's jump straight to C. All the planets have radius between 0.60 and 0.771 Jupiters, and only 13 has an orbital period of more than 10 days. Now, this is also wrong because, as we mentioned before, only planet 14 has an orbital period of more than 10 days. And it is not planet 14, making answer choice C wrong. Now, for the last one here, each of the planets has a mass greater than 0.25 Jupiters. Now, this is correct because, as we noted here, all planets have a mass more than 0.25, and all except for planet 14 have an orbital period of less than 10 days. Now, we instantly notice except and orbital period of less than 10 days. This directly supports our evidence that it is planet 14 by noting the difference in days for both hot Jupiters and warm Jupiters, proving the points that there are in fact 4 hot and 1 warm Jupiter only, making answer choice D correct. Now we're going to finish off with a harder question over here, and I just want to note that instantly this question may seem harder than the previous two ones, because the first thing we lay our eyes on are just the hard scientific names, which nobody understands and probably most of you don't even know the meaning of. However, I want to remind you that the SAT is trying to test your ability to shorten the paragraph into simple points and get the main idea out of it without getting distracted by long scientific terms and overall fluff which is meant to distract you. Neither is it trying to test your external knowledge, so if you don't know what boofo tadpole is, you're going to be fine. Now again, I suggest you to stop this video and try it for yourself. However, if you already got the question and stopped it, then we're going to begin by skimming the graph quickly. And instantly I noticed some tadpole body mass and toxin production. Then over here we can see population density, some mass. I quickly note some bee toxins per tadpole, average amount of bee per tadpole, average something concentration. Then I instantly see high, medium, and low. And from this context, I just can kind of assume it's going to talk about tadpoles, mass, and some bee gas, which we're going to find out about. Now, jumping straight to the question, which choice uses data from the table to most effectively support the researcher's conclusion? Oh, we see conclusion, and instantly conclusion is going to be in the last sentence. So we jump to the last sentence and see that based on analysis of tadpoles after 3 weeks, the researchers concluded that increased competition drove bee production at the expense of growth. So from this point, we can kind of shorten the conclusion made by the researchers and say that some increased competition drove bee production, and this required to sacrifice growth. And by growth, we can kinda assume that it means body mass, because in the paragraph we noted that it talks about some kind of a mass in tadpoles. And to make it into our small bullet point, we can just write that competition equals growth in B and lowering in mass. And this basically makes a short bullet point of the researcher's hypothesis, and we will need to be looking for evidence for that hypothesis in both the paragraph and the table. What we want to be specifically paying attention to while skimming through the passage are words like competition, bee, or growth, so when we notice them, we stop and pay closer attention. Now let's go to the back part of the paragraph and begin reading. Ecologist E investigated within species composition. We see competition. Common toads, let's call them BU since we already used B. A species that secretes various unpleasant tasting toxins called B in response to threats. Now, basically from this we can make a bullet point that B is a response to threats by BU toads. And at this point we can keep reading. The researchers tested BU tadpoles' responses to different levels of competition. We see competition again. By creating ponds with different tadpole population densities. Now, at this point, population densities are what we'll refer to as competition, and this is good because in the graph we see the word competition population densities, but a fixed amount of food. Now, basically, what we can turn this bullet point is that some researchers put tadpoles in different amounts of population densities, like high, medium, and low, but they all had the same amount of food. And basically what we'll need to prove here is that as competition rises, bee production raises while growth lowers. Now, We want to be looking for a graph here and finding evidence for this, and instantly we look at mass and bee production. So we see that as population density rises, meaning competition rises, our mass is going to become lower. And when we look at bee production here, we notice that as population density rises, our bee production is going to also rise. Now, from this point on, we want to jump straight to the answer choices to see which one fits the hypothesis. And let's begin with A. The difference in average tadpole body mass was small between the low and medium population density conditions, and substantially larger between the low and high population density conditions. Now, in this answer choice, it does talk about mass or growth and population density conditions. However, what isn't mentioned is bee production, which is important if we want to prove that with competition, B is going to rise. So since B isn't mentioned, answer choice A is automatically wrong. Now for answer choice B, tadpoles in low and medium population density conditions had substantially lower average B concentrations but had greater average body masses than those in high population density conditions. Now in this one it talks that if it were in low and medium population density conditions, then there was lower bee production. However, the average body mass was higher than those in high population density conditions. And this does support their claim because we would expect as competition rises for bee production to also rise and growth to lower, which means that in higher population density conditions, the bee will be higher and growth will be lower than in those compared to low and medium density conditions, which makes us leave B for a while we jump to option C. Tadpoles in high population density conditions displayed a relatively modest increase in the average amount of B, but roughly doubled the average B concentration compared to those in the low population density conditions. Now we notice that in this answer choice it doesn't talk about growth like mass at all, which is instantly a red flag, and we throw this option out because we also need it to talk about mass, which isn't talked about. And for the last answer choice here, tadpoles produced approximately the same number of different BE toxins per individual across the population density conditions, but average tadpole body mass decreased as population density increased. Now for this answer choice, the second part about body mass decreasing as population density increased is correct and it falls within our hypothesis. However, the first part about the same amount of different B toxins per individual being the same across density conditions is wrong because we see competition rising, so D is wrong and B is our correct answer. So this wraps up this SAT quantitative evidence question tutoring video. If you have any questions, feel free to leave them in the comment section and I'll try to answer as many as I can. Also, if you think you need help with preparing for the SAT, I left a link for the website in the description so you will check it out, maybe you'll find something helpful. Anyways, thank you for watching and comment on what I shall make a video next.